Hi, today we will see the working principles of high pressure boilers from the basic mechanical engineering. The high pressure boilers in applications where the steam needed the pressure 30 bar and individual boilers are required to raise about the 3000 kg. Steam per hour shell boilers are considerably cheaper than the water tube boiler. Above these limits, shell boilers are difficult to transport, if not impossible. There are no such limits to water tube boiler. This can be site erected from easily transportable parts, and moreover the pressure parts are smaller diameter, therefore can be thinner. The geometry can be varied to suit wide range of situation, and furnace is not limited to the cylindrical form. Therefore, the water tube boilers are generally preferred for the high pressure boiler and high output, whereas the shell boilers for the low pressures and low output. The modern high pressure boilers employed the power generations are for steam capacities 30 to 650 tons per hour and above, with pressure up the 160 bar. The maximum and the 160 bar and the maximum steam temperature is 540 degrees centigrade. At the lowest point of the boiler is provided a mud of collector to remove the mud particles through the blow down cock. The entire boiler except the furnace is using the hung by means of metallic slings and straps, wrought iron girders, and supported on the pillars arrangements enables to drum and the tubes to expand and to contract freely. The brickwork around the boiler encloses the furnace, the hot gases, the various mountings used in the boilers, the Bangkok Velux water tube boilers with cross drum of differs from the longitudinal drum boilers in a way that how the drum is placed with reference to the axis of the water tubes. At the boilers, the longitudinal drums restricts the number of tubes that can be connected to one drum and circumferentially, and limits the capacity of the boiler in the cross drum, or one cross drum boiler may be as high 100 bars and steam capacity up to 27 kgh. High pressure boiler, Lamont boiler, a forced circulation boiler, was the first introduced Lamont the year of 1925, which is used in Europe, America. This is a modern high pressure water tube type steam boiler working on a forced circulation systems, and the working principles: the steam separator drum. The Lamont boiler consists of the steam separator drum and placed wholly outside the boiler settings. The drum receives a mixture of steam and water from the evaporated tubes and feed water from the economizer. The steam is separated from the water in the drum circulating pump. The water from the drum is then drawn to the circulating pump through the down corner. The pump circulates the water 8 to 10 times the weight of the steam evaporated This prevents the tube from being overheated. Distributing header. The circulating pump delivers the feed water to the distributing header with orifices at the pressure above the drum pressure evaporator. The header distributes the water through the orifices to the evaporated tubes acting parallel. The orifices either control the flow of water to the evaporated tubes. Here the part of the water is evaporated and a mixture of steam and water from these tubes enters the drum. Convection superheater. The steam produced in the boiler is necessarily saturated. The steam as such should not be used as a steam turbine. The presence of moisture in it will be cause the corrosion of turbine blades, etc., to raise the temperature of the steam, thereby to increase the turbine efficiency. The superheater is used. The principles of convection of superheater is similar to the steam generating tubes of the boiler. The outflow gases at high temperatures sweep over the convection, the superheated tubes, and raise the temperature of the steam. The convection of superheater thus receives the heat from the flue gases flowing from the combustion chambers entirely by convective heat transfer. Such superheater may be more conveniently located since it is not necessary for it to see the furnace. The saturated steam from the top of the drum enters the convection of superheater placed in the part of the flue gas and a superheated steam outlet. The superheated steam from the superheater passes out to the steam turbine through the steam outlet. Economizer. The quantity of superheated steam thus delivered to the turbine is continuously made up in the form of the feed water. The feed water supplied by the feed pump is heated in the economizer on its way to the steam separator drum. The economizer is a device used to preheat the feed water using the hot gases leaving the boiler. Before the gases are let off the atmosphere, they are made flow to indefinite passage in the economizer so that some of the heat in the hot gases which otherwise gets wasted can be used. Preheat of the feed water. The preheated water requires only for the small amount of heat to be supplied in the boiler, resulting in some savings of fuel burnt. This results in an increase in the boiler efficiency. The air preheater. Since the heat of exit gases cannot be fully extracted through the economizer, the air preheater is employed to recover some of heat escaping in these gases. These exit gases preheated the air from the blower in the preheater. The preheated air is supplied to the furnace for the combustions. Capacity. The capacity of the Lamont is 50 tons per liter of superheated steam of pressure 170 kgf square centimeter and 500 degree centigrade. Bunsen boiler. In the Lamont boiler, main difficulty experienced is the formation of attachment of bubbles on the inner surface of the heating tubes. The attached bubbles to the tube surface reduce the heat flow steam generation as it offers high thermal resistance than the water flame. The Benson in 1922 argued that in the boiler pressure was reached in the critical pressure, the steam and the water have the same density, and therefore the danger of the bubble formations can be easily eliminated. This boiler too makes the use of forced circulations and uses of the fuel. The chief novel principle is that eliminates the latent heat of water by the first compressing the feed pressure to 35 bar. It is then above the critical pressure and latent heat is zero. This boiler does not any drum the feed water after circulations through the economic tubes flows through the leading parallel tube sections to evaporate partly. The steam water mixture produced then moves to the transverse sections. When this mixture is converted into steam, the steam is now passed through the convection superheater and finally supplied to the prime mover. The boilers having as high as 650 degrees centigrade temperatures and the steam has been put into the service. The maximum working pressures obtained so far from the commercial Benson boiler is 500 at atom. The Benson boilers 150 tons generating capacities are in use. Advantages of Benson boiler. The Benson boiler process is following advantages. It can be erected in comparatively smaller floor area. The total weight of the Benson boiler is 20% less than the other boilers since there is no drums. This also reduces the cost of the boiler. It can be started very quickly because of welded joints. The natural convention of the boiler requires the expansion joints, but these are not required for the Benson boiler at the pipes are welded. The furnace walls of the boilers can be more efficiently protected by using the smaller diameter and closed pitched tubes. The transfer of parts of the boiler is easy as no drums are required and majority of the parts are carried to the site without the pre-assembly. It can be operated the most economically by varying the temperature and the pressure parts, loads and overloads. The desired temperatures can also maintain the constant in any pressure. The blowdown losses of the boiler are hardly 4%. Natural circulation of the boiler of the same capacity. The expulsion hazards are not severe as it consists of only the tubes of small diameter has very little storage capacity. The superheater in the Benson boiler is an integral part of the forced circulation systems. Water tube boilers. Water circulates inside the tubes. Hot flow gases surround the water tubes. Bangkok and Lamont Benson are examples of the water tube boilers. It can be generous as high as 200 bar. The rate of the steam generation is high. The thermal efficiency is high. The risk of bursting due to the high steam pressure is suitable for the power plants which generates the electrical power. It occupies the more space. Service maintenance is high. The furnace is located outside the boiler shell. Any type of the fuel can be used. Hot flow gases passes through the tube and the water surrounds the tubes. Coherent locomotive Lancashire boilers are examples of the fire tube boilers. It can be Generally, the steam at the pressure up to 25 bar, it is low and low risk, not suitable for the power plants, occupies less space, it is low. The furnace is located inside the boiler, only the coal can be used. The boiler mounting, the items such as stop wall, safety valve, water level gauges, fusible plug, and blue cock valve, pressure gauges, water level indicator, and termed as mountings are essential for safe and full operations of boiler. The boiler cannot be work safety without them. The water gauges indicator, it indicates the water level inside the boiler, hence it is called the water level indicator. Usually two water gauges are fitted in front of the boiler. It warns the operator if the water level goes below the fuel mark, so that the corrective actions may be taken in time to avoid any accident. For observations of water level in the boiler, the water steam cocks are opened and drain cock is closed. The steam is enters from the upper metal tube into the glass tube, and the water enters from the lower metal tube M2 to glass tube. Hence the water stands in the glass tube at the same level as in the boiler. The pressure gauge is used to indicate the steam pressure of the boiler. It is also called as a strain gauge. It is usually mounted in front of the top seal drum. Shows the commonly used pressure gauge is known as the Borden type pressure gauge. It consists of an elastic elastic metallic burden and the spring tube 5 of the elliptical cross section, and built in the form of the circular arc, and one end of the tube is fixed in at the block B. It is connected to the stem of the space of the boiler by means of the cock C. The another end is connected to the toothed sector and to T through the link L hinged at a point H. The sector is in the mesh with the piston. Pinion P is fixed on the spindle, and indicating pointer N is attached the spindle to read the pressure on the dial gauge D. When the steam enters into the elliptical tube, the tube sections tries to become the circular, which causes the other end of the tube and moves outward, and the become the circular and causes the other end of the tube to move outward. The movement is closed closed and end of the tube is transmitted, magnified by the link and toothed sector. The magnitude of the movement of the sector is indicated by the pointer on the dial. The safety valves are closed valves devices used to maintain the constant state of the pressure inside the boiler, and when the pressure inside the boiler increases, the assess the steam and will escape to the atmosphere through the valve automatically. And generally a boiler is provided with two safety valves. These are four different types of safety valves, and namely lever type safety valve, spring loaded safety valve, high steam valve, water safety valve, lever safety valve. The advantages of lever safety valve is a overhead dead weight safety valve. The heavy dead weight is replaced by the lever with a smaller weight. It consists of a valve resting over a gunmetal seat. The valve seat is fixed on a mounting block fitted over the boiler shell. One end of the lever is hinged on the rod mounting block, while the other end carries the weight of short strut placed over the valve. The thrust over the lever with a weight is transmitted to the valve by the strut of the stream is pressure exceeds the safe limit. The upward thrust is the stream lifts the valve and from its seats and the lever with its weight. The excess stream escapes till the pressure valves back to the normal value. The valve is returned back to its original closed position. Fusible plug. The function of fusible plug is put off to the fire in the furnace of the boiler when the water level falls below an unsafe level. This avoids the explosions which may takes place due to the overheating tubes and the shell. It consists of hollow gunmetal body screwed onto the firebox down plate. The hollow gunmetal plug is screwed into the gunmetal body by tightening the hexagonal flange in it. There is another copper plug and locked with gunmetal plug by pouring the low melting point metal into the groove provided for the seam. During the normal operations, the fusible plug is submerged in the water, which keeps the temperature of fusible metal below its melting point. But when the water level falls below the top of fusible plug, it is covered by the water. The fusible plug therefore melts by the heat of the furnace. This the copper plug drops down and is held within the gunmetal body by the ribs. The opening so made allow the stream rush into the furnace, extinguish the fire. This damage to the firebox is prevented. Cogeneration is in the use of the heat engines or power station simultaneously generate both electricity and useful heat. It is the one of the most common energy recycling in generation of electricity. Large amount of the heat energy is remains in the exhaust stream from the steam turbine or hot gases from the gas turbine. On the other hand, many industrial processes use the higher temperatures heat textile, cement, pulp and paper, food processing, fertilizers, petroleum refining, steel and glass industries are the examples. There is often much heat energy left in the exhaust from such industries. The waste heat both above the cases of energetic and is therefore potentially capable of producing useful work in the form of the process steam or electricity. A plant producing electricity, heat and cold is sometimes called the generation or more generally the polygeneration plant. Cogeneration is thermodynamically efficient use of the fuel in separate productions of electricity. Some of the energy must be rejected the waste heat, but The cogeneration is the thermal energy into the good use. Use of the cogeneration, the power produced by an industrial cogeneration systems is the byproduct of the process, which may be or may not match with the power demands of the industries. Electricity is obtained by the industries through the cogenerations consumes only about half of the fuel, and the conventional power station needs to generate it. The cogeneration systems of the fuel efficiency of 60% to 70%, whereas latter has not more than 30 to 50%. Important direct benefits flowing from the fuel economy include the savings in transportations. The cost of the fuel will reduce the pollutions. It is the source of conservation of fuel. Cogeneration is the convenient way of improving the energy efficiency. Cogeneration entitle the simpler equipment to use a lower temperature and pressure and almost completely obviate the transmission and distributions, and the refrigeration and air conditioning. The refrigeration is the process of removing the enclosed space or from the substance and moving it to the place in unobjectionable, and the primary purpose of the refrigeration is lowering the temperatures of enclosed space of the substance, then maintaining the lower temperatures. The term of cooling refers generally to any natural artificial process which the heat is dissipated. Cold is absence of heat, hence the order decrease the temperatures once the remove the heat rather than adding the cold. Ice refrigeration, air refrigeration, and vapor refrigeration. Ice refrigeration, it is the oldest methods practiced in past. It consists of an insulated cabinet equipped with a tray and at the top for holding the blocks of the ice places. The shelves for food are located below the ice compartment. The cold air flows downward from the ice compartment and it cools the food and shelves below. Air returns from the bottom of the cabinet up. Because of the convection, the sides and the back of the cabinet, which is warmer, flows over the ice and again flows down. The shelves are cooled. The air refrigeration. In the air refrigeration cycle, the air is used as a refrigerant. In olden days, air was widely commercial applications because of its availability at free cost. Since the air does not change its phase in examples, remains gaseous through the cycle. Therefore, heat carrying capacity per kg of air is very small as compared to the vapor absorbing systems. Air cycle refrigeration systems, as originally designed and installed, are now practically obsolete because of their low coefficient of performance and higher power requirements. However, the systems is continuous favored for the refrigeration because of low weight of the volume and equipment. The basic element of an air cycle refrigeration are the compressor, the cooler, heat exchangers, expander, and refrigerator. The vapor refrigeration systems. The vapor is subdivided into vapor compression refrigeration, vapor absorption refrigeration. The terminology of refrigeration is refrigeration, refrigerator, refrigerant, refrigeration effect, capacity of refrigeration, 1 ton of refrigeration, coefficient of performance. It is the process of removing the heat from the body to reduce its temperature lower than that of the surrounding refrigerator. It is the mechanical device used for maintaining the temperatures in the space below the atmospheric temperature. Refrigerant. It is a working fluid used into the refrigerator. Liquid whose the saturation temperature is below the temperature to produce the refrigerations is chosen the refrigerant such as liquid will evaporate at low temperatures and will absorb the heat extended from the surroundings. The refrigeration effect, it is defined as the rate of which the heat is removed from the space to be cooled or the cycles. It is expressed in kilojoules per second. Capacity of refrigerator, that is the rate of the heat can be exerted from the cooled body. In example, the rate which the refrigeration can be produced, it is expressed in terms of the ton of refrigeration. 1 ton of refrigeration is equal to amount of refrigeration produced by melting the 1 ton in 24 hours. 1 ton of refrigeration is equal to 3.5 kilojoules per kg, 3.5 kilowatt. The coefficient of performance is a measure of effectiveness of performance of the refrigeration systems. It is defined as a ratio of extracted in a given time to the work done is always greater than the coefficient of performance. The compressor is the function is convert into the low pressure vapor refrigerant into the high pressure vapor condenser. The condenser is to convert the high pressure refrigerant into the vapor into the high pressure liquid refrigerant. Principles of refrigeration. The refrigeration means to consider the attraction of heat from the body whose temperatures is already below the temperatures, the temperature of its surroundings. For example, some space of degree will extract the heat brought into the with the articles is stored after temperature is once reduced to 5 degrees centigrade. The heat is pumped to the lower temperature to the higher temperature. The second law of thermodynamics. It is impossible to self-acting machine working in a cyclic manner to transfer the heat from the body at a lower temperature to the higher temperature without the aid of the external agency. The laws of thermodynamics. When the two systems of the thermally equilibrium with the third systems, then the two systems are also thermal equilibrium to the another. The first law of thermodynamics. The first law of thermodynamics is equal to the heat work transfer. In other words, the cyclic integral heat transfers to the work transfers. The energy can be neither created nor destroyed. It can be transferred from one form to the another form. According to this law, when the systems undergo the change of state, both heat transfers and the work transfers takes place. The heat and the net energy transfer is stored within the systems is known as the stored energy. The symbol is used for the quantity of differential symbol is used for the extensive property of represents the total energy of the system for the particular states. Second law of thermodynamics. This may be Kelvin Planck. It is impossible to construct an engine working in a cyclic process whose the sole process is to convert the each energy from the single thermal reservoirs into the equivalent amount of work. In other words, no um, in other words, no actual heat engines. The working cyclic process can convert the heat supplied to heat into the mechanical work. It means there is a degradation of the energy in the process of producing the mechanical work from the heat supplied. Thus, the Kelvin-Planck's treatment of the second law of thermodynamics is sometimes known as a degradation of the energy. According to the classic statements, it is impossible for the self-acting machines working in cyclic process to transfer the heat from the body at a lower temperature to the body at higher temperatures without the aid of the external agency. In other words, the heat cannot be flow itself from a cold body to the hot body without the help of the external agency. Refrigerant. The refrigerant is a heat carrying medium during the cycle, the compression, condensation, expansion, evaporation. In the refrigeration systems absorb the heat. Low temperature systems which discard the heat, so absorb them into the high temperature systems. The properties of ideal refrigeration is low boiling point, low specific heat, latent heat of vaporization, low specific volume, reduce the size of the compressor, should not have any bad effect on the stored material of any leakage, should have the high coefficient of performance, non-explosive, non-inflammable, non-toxic, non-corrosive, easy to liquefy and mixes with oil. Classification of refrigerants. The refrigerants may be broadly classified the following groups: primary refrigerant and secondary refrigerant. The refrigerant which directly take a part of the refrigeration systems are called primary refrigerants, whereas the refrigerant which are first cooled by primary refrigerants and then used as cooling purposes is called the secondary refrigerants. Halocarbon refrigerants, isotope refrigerant, inorganic refrigerant, hydrocarbon refrigerants. Hydrocarbon refrigerant is American Society of Heating the Refrigeration Systems. 42 halocarbons compound of refrigerant in R11 and R12, R13, R14, R21, R22, R30, R40, R100, R113, R114, IM5. This is used as a respiration number. Halocarbons are synthetically produced where the Freon family represents the Freon registered trademarks of EI DuPont of and Co. of America. Most of halocarbon refrigerants are now available to manufacturers. The trade names that R12 was developed by the 1930. The various halocarbon refrigerants and the R11, the synthetic chemical product can be used as a refrigerant. It is stable, non-flammable, non-toxic. It is considered the low pressure refrigerant. It has a low side pressure of 0.202 bar at 15 degrees centigrade and high side pressure 1.260 or 6 bar at 30 degrees centigrade, 23.77 degrees centigrade. Due to its low operating pressure, the refrigeration is exclusively used for the large centrifugal compressors systems of 20 ton or above. The leakage may be directed to by using the soup solutions, halide, or by using the electronic detector. R11 is often used for the service technicians as flushing agents for cleaning the internal part of the refrigerator of the compressor and overhauling systems. It is useful after the systems had the motor burnout, after the great deal of the moisture in the systems by flushing the moisture, and R11 is evaluation time is shortened. R11 is one of the safest cleaning solvent can be used for this purpose. R11 is orange. R12 R12 is a very popular refrigerant. It is the colorless, almost odorless liquid. The boiling point is minus 29 degrees centigrade. It is the atmospheric pressure. It is non-toxic, non-corrosive, non-irritating, non-flammable, and it has a relatively low latent heat value, which is advantageous in small refrigeration machine. Large amount of refrigerant is circulated will permit the permits operates at low but positive head and back pressure and with the good volumetric efficiency. This is the refrigerant used in many different types of industrial commercial applications such as refrigerators, freezers type, and industrial and the commercial applications such as refrigerator, freezers, and coolers, and the room windows, air and the air conditioning units, etc. The use and principal use is found reciprocating rotary compressors, but it uses centrifugal compressors for large commercial air conditioning is increasing. R12 pressure is 0.82 bar and 15 degrees centigrade, and pressure is 6.4 bar 30 degrees centigrade. Then the latent heat R12 is 15 degrees centigrade, and the leakage directed by the soup solutions and solid touch the an electronic leak of detector of water is only slightly soluble in R12, and at 18 degrees centigrade it will hold and 6 parts per million by mass. The solution is formed very slightly corrosive to any common metals used in refrigerator construction. The addition of mineral refrigerant has no effect upon the corrosive action. R12 is more critical moisture concerns when compared to the R22 and R502. It is soluble in oil below the minus 60 degrees centigrade. The oil will begin to separate at these temperatures due to the lightness of the refrigerant. It will collect on surface of the liquid refrigerant. The refrigerant is available variety of cylinder sizes and cylinder color code is white. The mono R13 is the boiling temperature is minus 81.5 degree centigrade, and the temperature is 28.8 degrees centigrade. This refrigerant is used for the low temperature side gasket systems. R14 is the boiling temperatures minus 120 degrees centigrade. Atmospheric pressure critical temperature is minus 45.5 degrees centigrade. Inorganic refrigerant. The inorganic refrigerants were exclusively used before introduction to the halocarbon refrigerant. These refrigerants are still used in the inherent thermodynamics physical properties. There is no such refrigerant maybe can be used for all operating conditions. The reciprocating compressors and other refrigerants are the best suited for the centrifugal or rotary compressors. Therefore, in order to select the correct refrigerant, it is necessary that it should be satisfied those properties which makes its deal to be used for a particular application. We shall the thermodynamical and chemical properties, the types of refrigeration, vapor compression refrigeration, vapor absorption refrigeration, vapor compression refrigeration. Vapor compression refrigeration is an improved type of the air refrigeration systems which is suitable for working the substance and termed as a refrigerant is used. It condenses and evaporates the temperatures and pressures close to the atmospheric conditions. The refrigerant is usually used for the purpose ammonia, carbon dioxide, sulfur dioxide. The refrigerant used does not have a systems but circulated through the systems alternately condensing and evaporating. In evaporating refrigerants absorb the latent heat from the brine which is used to circulating it around the cold chamber, while condensing it gives the latent heat circulating water of the cooler. The vapor compression refrigeration systems is therefore latent heat pump as it pumps and the latent heat from the brine it delivers it to the coolers. The, the vapor compression systems is nowadays used for all purpose refrigerations. It is generally used for all industrial purposes from a small domestic refrigerator to a big air conditioning plant. The compressor, the low pressure temperatures with the vapor refrigerant from the evaporator is drawn to the compressor through the inlet section wall. It is compressed by the high pressure, high temperature vapor refrigerant is discharged to the condenser through the delivery and discharge valve. The condenser or cooler consists of coil or pipe in which the high pressure, high temperature vapor refrigerant is cooled and condensed. The refrigerant while passing through the condenser gives up the latent heat to the surroundings and the condensing medium which is normally air and the water receiver. The condensed liquid refrigerant from the condenser is stored in the vessel known as the reservoir from where it is supplied evaporator through the expansion valve or refrigeration control valve. The expansion valve it is also the throttle valve and refrigerating valve. The function of expansion valve is to allow the liquid refrigerant under the high pressure and high temperature passes through the controlled rate of reducing heat, the pressure and temperatures. Some of the liquid refrigerant evaporate as it passes through the expansion valve. Greater portion vaporized in the evaporator at the low pressure, low temperatures. The evaporator consists of coil of pipe in which the liquids of vapor refrigerant at low pressures and the temperature is evaporated and changed into the vapor refrigerant at low pressure, low temperatures. In evaporating the liquid, vapor refrigerant absorbs its latent heat vaporization from the medium which is to be cooled. In any compression refrigeration systems, there are the two different pressure conditions. One is called high pressure side, other is known as the low pressure side. The high pressure sides is includes the discharge line and the delivery valve and condenser receiver expansion valve. The low pressure side includes the evaporator piping from the expansion valve to the evaporator and the suction line. The vapor absorption refrigeration. The vapor absorption refrigeration system is one of the oldest methods of producing the refrigeration effect. The principles of vapor absorption was first discovered the Michael Faraday 1824 while performing the set of experiments liquefy the certain gases. First vapor absorption refrigeration machine was developed by the French scientist. The vapor absorption systems uses the heat energy instead of mechanical energy as in the vapor compression systems in order to change the conditions of refrigerant and for the operations of the refrigeration cycles and the functions of compressors, the vapor compression systems, the temperature and pressure and the air on the cooling agents in the condenser so that the high pressure vapors can reject the heat condenser. The liquid refrigerant leaving the condenser is now ready to expand the evaporator conditions again. In the vapor absorption system, the compressor is replaced as the absorber pump. The generator and pressure reducing valve. These components in the vapor absorption systems perform the same functions as the compressor in the vapor compression systems. In these systems, vapor represent from the evaporator is drawn into the absorber, absorbed by the weak solutions. The refrigerant from forming the strong solutions. The strong solutions is pumped. The vapor refrigerant is driven off. The solution enters into the condenser where it is liquefied. Simple vapor absorption systems. The simple vapor absorption systems is consist of absorber, pump, generator, pressure reducing valve. Replace the compressor of vapor compression systems. The other components of the systems are condenser, receiver, expansion valve, evaporator, and vapor compression systems. In these systems, low pressure ammonia vapor having the evaporator enters into the absorber where it is absorbed by the cooled water in the absorber. The water has ability to absorb very large quantity of ammonia vapor. The solution thus formed is known as the aqua ammonia. The absorption of ammonia vapor in the water lowers the pressure in the absorber, which in turn draws the more ammonia, and some form of cooling arrangement is employed in the absorber to remove the heat solutions evolved there. This is the necessary in order to increase the absorption capacity of the water because the higher temperature of the water absorbs the less ammonia vapor. The strong solution is formed in the absorber is pumped to the generator by the liquid pump. The pump increases the pressure of solutions up to 10 bar. The strong solutions of ammonia in the generator are heated by some external source such as gas stream. During the heating process, the ammonia vapor is driven off the solutions at high pressure, having behind hot weak ammonia solutions in the generator. The weak ammonia solution flows back to the absorber at low pressure after passing through the pressure reducing valve. The high pressure ammonia vapor from the generator is condensed in the condenser at high pressure liquid ammonia. This liquid ammonia is passed to the expansion valve through the receiver, then the evaporator. These complete the simple vapor absorption cycle. The simple absorption cycle, in order to make the systems of more practical, it is fitted with an analyzer, rectifier, two heat exchangers. The accessories help to improve the performance of working plant. The absorber, when the ammonia is vaporized in the generator, some of the water also vaporized and will flow the condenser along the ammonia vapor in simple systems. If these unwanted water particles are not removed before entering into the condenser, they will be entered into the expansion valve where they freeze, choke the pipeline in order to remove the unwanted particles flowing to the condenser. An analyzer is used. The analyzer may be built as an integral part of the generator or made separate piece of equipment. It consists of series trays and mounted above the generator. The strong solutions from the absorber and aqua from the rectifier are introduced at the top of the analyzer and flow downward over the trees and into the generator. In this way, considerable liquid surface area is exposed in the vapor rising from the generator. The vapor is cooled and most of the water vapor condenses so that mainly the ammonia vapor leaves the top analyzers. Since the aqua is heated by the vapor, less external heat is required in the generator. Rectifier, in the case of the water vapor are not completely removed in the analyzer, a closed type vapor cooler called rectifier is generally the water is cooled and may be of double pipe, the shell and the coil, or shell and the tube type. Its the function is to cool and further ammonia vapor leaving the analyzer so that the remaining water vapors are condensed. Thus only dry or ammonia vapors flows to the condenser. Condensate from the rectifier is rectified to the top analyzer drip return pipe. Heat exchangers. Heat exchangers provided between the pump and the generator is used to cool the weak and hot solutions returning from the generator to the absorbers. Heat removed from the weak solutions raises the temperatures of the strong solutions, leaving the pump and going to the analyzer generator. This operation reduces the heat supply to the generator and amount of cooling is required for absorber. Thus the economy of the plant increases. The heat exchangers provided between the condenser and the evaporator may also call the liquid subcooler. In this heat exchanger, the liquid refrigerant leaving the condenser is subcooled by the low temperatures ammonia vapor from the evaporator. Subcooled liquid is now past the expansion of the evaporator. In this system, refrigeration effect heat is absorbed by the refrigerant evaporator. The total energy supplied to the systems is sum of the work done by the pump, heat supplied, generator. Therefore, coefficient of performance is work done by the pump plus heat supplied to the generator. The advantages of vapor absorption systems over the vapor compression systems. In the vapor absorption systems, only one moving parts of the entire system is the pump and small motor. Thus, the operation system of this system essentially quite subjected to the little wear, and the vapor absorption systems the same capacity as more wear and tear, noise due to the moving parts of the compressor. The vapor absorption systems uses the heat energy to change the conditions of refrigerant from the evaporator, and the vapor absorption system uses the mechanical energy to change the conditions of refrigerant from the evaporator. The vapor absorption systems are usually designed to use the stream either mm, either it at high pressures or low pressure. The exhaust systems steam from the furnace, and the solar energy may also used. Thus, the systems can be used where the electric power is difficult to obtain or very expensive. The vapor absorption systems can operate at reduced evaporator pressure and temperatures by increasing the steam pressure to the generator with a little decrease in capacity, but the capacity of the vapor compression systems is drops rapidly mm, with lowered evaporator pressure, and load variations does not affect the performance of vapor absorption systems. The load variations are met by controlling the quantity of aqua circulated and the quantity of the steam is supplied to the generator, and the performance of vapor compression system or at partial loads is poor. In the vapor absorption systems, the liquid refrigerant is leaving the evaporator has no bad effect on the systems except that the reducing the refrigeration effect in the vapor compression systems is essential to superheat vapor refrigerant systems, leaving the evaporator so that no liquid may enter to the compressor. The vapor absorption systems, the capacities are well above 1000 tons of refrigeration each, which largest size of the single compressor unit. The space recommends of automatic control recommends favor absorption systems or more and desired evaporator temperature drops. Thank you. We will see in next video.